Hello! So let's talk a bit about opportunities and challenges of micro frontends, but also about alternatives. And for this, I want to get started with a picture. So what do you see here on this picture? What you see here seems to be a couple and another couple. They seem to be neighbors and they seem to like each other. They seem to have a good relationship. They are smiling, they are communicating with each other, and so on. But you see something in addition, namely fences. And this brings me to this good old proverb, good fences make good neighbors. And this proverb is also true when it comes to software development, especially when it comes to enterprise scale software systems. Because what we usually want to achieve is, usually we want to slice our huge systems into verticals. Parts, subsystems that don't need to know much about each other. They should not know much about each other to stay maintainable. The goal is to change something here without breaking something there. And usually those verticals contain some co-located features, some features that go together, that need to know something about each other. And usually we can make sure that the dependencies between those verticals are minimized. In a perfect world, they don't know a thing about each other. In this world, sometimes they need to exchange some data, or perhaps sometimes they need to share some code. And at the end of the day, we do this to be capable of assigning different teams to those verticals. Teams that can concentrate on this very vertical and teams that can provide business value on a regular basis. Teams that don't need to communicate with each other all the time when they want to implement something. At the end of the day, this gives us back maintainability. And it gives us back the agility of small teams, even though we have a huge overall software system. When it comes to those verticals, normally they should represent a business domain, an area from the real world we are writing our software for. You know, the real world is where the pizza boy comes from, and usually we look out there to the real world, we analyze those parts of the real world, and then we model those parts in different verticals. So ideally, we mirror the business domain, and one option for implementing those verticals is going with micro frontends, which means that each and every vertical becomes an application of its own, a front end of its own. And this maximizes the independence between the different teams working on those verticals. Because now everything is really decoupled. And this brings some opportunities. Because we have minimized the dependencies between those teams, the teams are more or less autonomous. They can do more or less what they want. Of course, they have to align with some decisions, but within the borders of those decisions, they can do what they want. And so this brings back a lot of agility. We can easily add new team members or even additional teams, because a team is only responsible for one vertical, so they only have to concentrate on this subsystem. They don't have to concentrate on everything. So adding new people to such a team is easy, but also adding additional teams that work on additional verticals is easy. This results in shorter release cycles. So from a business perspective, the goal is time to market. And time to market is now faster because the teams just need to concentrate on their stuff. This increases the testability because we don't have to focus on the whole system anymore. We also have fault isolation. If we break something here, this will hopefully not affect something in other verticals. This also improves runtime performance because we now have smaller subsystems. And usually we don't use all the systems at once. And in theory, we could even go with different technology stacks. In practice, this is more or less an anti-pattern because we don't want to have a framework zoo, but this might make sense in the mid or long term. Because we all know in the mid or long term, we have to migrate to another technology stack. Technologies come and go, and after a decade, plus minus, we need to migrate. And so having the opportunity to migrate little by little is for sure a huge benefit. However, micro frontends also come with several challenges. Somehow we need to make sure that we have a unified UI and UX. We have to take care of initial loading times, which means we should not load all the micro frontends at once. We need to take care about coupling. In theory, the micro frontends are really decoupled, but in practice, decoupling them all the times is really difficult because overall they depend to an overarching system. They belong to an overarching system, and so it's not a surprise that sometimes they need to share something. We might have technical conflicts because if we load several applications, micro frontends into a browser window, they could conflict with each other. After all, they don't know each other, and we are using different frameworks perhaps that have not been officially tested with other frameworks or other versions with themselves in the same browser window. This might increase the complexity. To be honest, on one side we are decreasing the complexity, but if we look a bit closer, we see that we are just moving the complexity out of the verticals into the integration layer of those verticals. The verticals themselves might become simpler, but somehow we need to integrate them to an overarching system, and this is what creates some additional complexity. And we might have diverging micro frontends, where different teams develop the micro frontends in some directions so that they don't fit together anymore, on a technical level or on an UI UX level and so on. So those are the challenges. The big question that I want to answer with this presentation here is how to deal with these challenges. And for this I've prepared 3 things for you. I'm getting started with strategies for dealing with these challenges. Then I want to show you the costs of those strategies. Nothing is for free, and so we should talk about the costs. And then I want to talk about alternatives. Perhaps you say, well, micro frontends pay off even though there are costs, or you say, well, they don't pay off in my very case, and in those situations you want to look for alternatives. Okay, so let's get started with strategies for dealing with challenges. One challenge area is UI UX. We want to have a unified UI UX. And to achieve this, we can do several things. We can provide an overarching design system. I would say in general, having a design system makes a lot of sense, regardless if you go with micro frontends or not. And this design system can also result in shared styles, but also in shared libraries. And we can deal with Shadow DOM to isolate different parts of the system away so that a special style from here is not affecting the styling over there. When it comes to initial loading times, we can go with server-side rendering. This is something we might need even though we don't go with micro frontends. Because if initial loading times are critical, server-side rendering and hydration and all those other strategies that tie into this are king. We might want to go with automated performance checks. For instance, we could run Lighthouse in a headless mode to get statistics on a regular basis and to get a bell ring when we surpass a given threshold. And at the end of the day, it's also about sharing code. Just because we have 10 micro frontends that need Angular does not mean we need to download Angular 10 times. This would be quite an overhead. Ideally, we just download it once and share it during runtime. And this is something that can be easily achieved with module federation that comes with Webpack and meanwhile also with other bundlers. When we go with federation, we have two roles, two kinds of applications. The first role is the host, which is our micro frontend shell. The second role is the remote, which is our micro frontend itself. And now we can configure both roles. For instance, we can define a mapping for the shell, a mapping that points over to this or that micro frontend. That means every time we import something from here, we grab something from over there. And over there, we can expose files. When we are exposing files, we assign them to a nice alias, because other roles, the shell is not interested into knowing our paths, our directories. The shell is not interested into knowing that this file is in the folder A, B, C, D. No, that's why we are just mapping a nice short alias. And then all we need is a dynamic import that is using the mapped names, and so we can grab over to a system we did not even know at compile time, and then we can load something from over there. The best about this is that we don't need to tweak our framework. We can use our framework, Angular, React, Vue or something else in a way it was intended to be used. No dirty tricks, no workarounds. It's business as usual for the framework, because the framework only sees the dynamic import, and so it thinks, okay, that's lazy loading. However, the truth is it's a bit more than traditional lazy loading, because we are loading something we have not been aware of at runtime. And yeah, this is what federation does for us underneath the covers. So one of the best things about federation is we can define all this data pointing over to another application in a dynamic way, because in a very dynamic system, this information might come out of a configuration file or of a service telling us, well, today please use this micro frontend over there, and tomorrow please use the newer version that is now located there. And also we need to share some metadata. For this we provide a so-called remote entry point, and this entry point needs to be loaded into the shell, so the shell knows how to interact with the micro frontend. This metadata, by the way, is also necessary to find out what to share with the micro frontends. This is why we started to talk about federation, didn't we? So in order to define what to share, we just need to define the names of the libraries to share on the left side and on the right side. And if we find out at runtime that we have the very same version of those libraries, or even a compatible version, then it will be shared. If there is no compatible version, then there are several strategies we can configure, several strategies how to deal with such a situation. Which means that dealing with version mismatches is part of the game. It's baked into federation. Now let's have a look at an example for all of this. So what we see here is a simple micro frontend. It's within the red dashed lines. And here we see a shell that has already loaded this micro frontend. Let's go to the home page, let's reload it, let's click here, and one more time, we've loaded this micro frontend seamlessly into the shell. That means even though we talk about two different applications, two applications that have been implemented by different teams, that have been deployed separately, the user gets the impression that they are dealing with one big thing, with one integrated thing. One of the best things here is that libraries are shared. So let's have a look at the network tab here. Let's reload everything. And what you see here is that all the program code, but also the libraries are loaded. Each shared library like Angular Common or Angular Common HTTP and so on. And when loading the micro frontend lazily, we don't need to reload Angular. Even though it was compiled with its own Angular, now it is just sharing Angular with the shell. And so we just need to load the source code of the application, which is here just a component, a matter of 3 kilobytes, 3 give or take kilobytes. So if we look into the source code of all of this, then we see we have really a traditional Angular application here. Actually both the shell, but also the host is, no, the shell, but also the micro frontend is a traditional Angular application. And it could also be a traditional React or Vue or Svelte application or something else. So no special things in there, but a federation config. This federation config defines a unique name. This is especially important for the micro frontends. Here we have a unique name that's called MFE1, like Micro Frontends 1. And micro frontends usually expose files like our application component. They are exposed and we assign a short alias to it. Then we can define what to share. And normally this here is an exhaustive list with all the libraries we want to share. All the libraries like Angular Core, Angular Common, and so on. However, the issue with exhaustive lists is they are normally exhaustive. And that's why I'm going a different way here. I've written this simple share all helper that looks up all my dependencies in my package.json and shares them. By the way, those settings here define how to deal with version mismatches. But this goes too far for today. Let's just assume we are sharing everything in our package.json and we took care with settings of version mismatches. If you find out that you don't want to share everything, well, you have this skip list here that allows you to skip some libraries from be shared. This accelerates your build process a bit. You have a similar configuration file for the shell. And then the shell also gets this federation manifest, a simple file that maps some names of the micro frontends to their locations. To be more precise, it's not the location of the micro frontend, it's the location of the remote entry file, which is the metadata file we've talked about before. This metadata file is generated for you for free. Federation takes care about this, and you just need to point to it. So just define the mapping here and define where to find the micro frontend with its remote entry. This here is a file of its own because usually you want to exchange this file when deploying your application. During your testing, you might have the micro frontend over there in your testing environment. And during production, it might be on a different location. So exchanging this file is a good idea. And perhaps you don't even exchange it. Perhaps you replace this file by a service, a RESTful service that gives you the necessary mappings. When we have defined everything, then all it takes is lazy loading. And usually for lazy loading, we use a dynamic import. A dynamic import that points to this or that file. Some relative path to this or that file could be a TypeScript file. And all we need to do now is to exchange the import, the dynamic import, for this helper function load remote module. Here we are pointing over to our micro frontend. This is the mapped name of the micro frontend. This is the mapped name of the exposed component over there. And then we define which export we want to have. And that's it. This is everything we need to do to lazy load our micro frontend. And as we have seen before, underneath the covers, our defined libraries are shared. Okay. So let's go back to the slides. Let's talk about further challenges we have when going with micro frontends. So one challenge for sure is coupling. In theory, the micro frontends are decoupled from each other, but after all, they are part of one overarching system. So sometimes they need to share data or share source code, as we have seen before. And to define a nice slicing between them, we can go with strategic design, which is a discipline of domain-driven design. It gives you a lot of theory for identifying parts of your overarching system that don't need to know much about other parts. There is never a perfect slicing, because sometimes we always have some dependencies, but the goal is to find some slicing that minimize those dependencies. So strategic design is for sure a good thing. Also, eventing is a good thing for loosely coupling our verticals, our micro frontend. Because when we go with eventing, we just emit an event when something happens, and the other micro frontends can react or not. If they are interested into this or that, they can react on the event, but no hard feeling if they don't react. This allows us to distribute data and information in our system. Can be done in the front end, can also be done in the back end when we want to distribute some domain events like product has been purchased, or product has been cancelled, or product has been delivered. Domain events, also this fits to strategic design and domain-driven design. Another approach is separate ways, where you deliberately decide to not share stuff. Perhaps you have similar things here and there, but you don't share it because you don't want to have the coupling. I mean, the first thing we learn about software design is don't repeat yourself. And don't repeat yourself makes a lot of sense, especially within a domain. However, when it comes to interaction between domains, we have don't repeat yourself on one side and loosely coupling on the other side. And usually we can't have both. So sometimes we have to decide upon if we want to increase coupling or if we want to have separate ways. Both is not possible, so we need to do a smart decision. We need to evaluate on a per case basis. And sometimes two things that have the same name on both sides are not really the same things. Think about a product. A product in your shopping basket could be another product compared to the product in reporting. Both is called a product and both might refer to the same thing in the real world, but we need a whole bunch of different data here and there. In reporting, perhaps we just need the price and the amount of products that have been sold. When it comes to the shopping cart, we need to have all the information, including pictures and recommendations and so on. So indeed, even though it has the same name, it might be a different thing. We might have a completely different perspective on it. So I think the key takeaway here is decide between don't repeat yourself and between reducing coupling. You can't have both. You can't have the cake and eat it. And inner sourcing is also a nice thing we can do. Inner sourcing means we do open source within a company. This gives us the best of both worlds. This allows us to share stuff. So not everyone needs to implement everything from scratch. But if we need something different, we don't need to wait for the maintainer of this library. We can fork it because it's inner sourcing. We can fork it and send over a pull request. Gives us kind of the best of both worlds, and it gives us agility. When it comes to domain-driven design and identifying verticals, identifying boundaries between our verticals and business domains, then you should look into event storming. It's really a nice strategy where people, domain experts and software development experts come together and try to model the business process with post-its. And this brings them together and this leads to a lot of discussions. And so we achieve a common understanding for the business process. And then we do the same with slicing. We try to slice the process into parts, into verticals, into micro frontends, into business domains. And also here, discussions will start. And one more time, this brings together the knowledge of the two important parties, namely domain experts and software development experts. So if you have such a project, have a look into event storming. It really pays off. Another area with challenges is technical conflicts. You might have naming conventions if you have technical conflicts after loading several micro frontends into the same browser window. You might go with iframes. I know this sounds funny going with iframes, but even though iframes come with a lot of drawbacks, they indeed also have some benefits. They have some benefits we don't find anywhere else. For instance, they isolate really well. With iframes, we can isolate the whole micro frontend away from other micro frontends and from the shell. That means grabbing over there, hacking it by intention or by accident does not work. It's really decoupled. And we have a well-defined messaging mechanism, post message, to get well-defined messages in there or out from there. That's why in critical environments like automotive or like online casinos, online gambling, iframes are quite usual. Even though you might not like them, even though they are not in the top 10 of the most famous HTML decks, they can serve some purposes. They isolate really well. Plus you can integrate everything, even legacy stuff. PHP code from the 90s or Java code, Java server phases or ASP.NET, Perl-based web applications. You can integrate literally everything. Of course, if you can prevent them, you will prevent them because they also come with several drawbacks. By the way, SAP is also using iframes for integrating their product in the cloud. They have an own framework called the SAP Luigi framework, like Mario and Luigi. Of course, if you can avoid it, you will do it. Also, import maps, script loaders and module federation, as seen before, allow us to prevent technical conflicts. They allow us to load something from over there, and they have some strategies to deal with version mismatches. And one more time, separate ways could be a nice thing to not share too much so that we don't run into conflicts. Complexity is another field with challenges. To deal with complexities, you can provide starter kits for your teams. You can provide utility libraries. You can provide meta frameworks and guidelines about how to use those meta frameworks. You can go with automated tests that also check if all the micro frontends play nicely together. And you can do a developer survey to find out where you find the pain points so that you can provide further guidelines, starter kits and utility libraries so that you can also adjust your automated tests. However, as we talk about all of those fields, of those areas with challenges, a lot of strategies for dealing with those strategies, or a lot of strategies for dealing with those challenges might make sense even without micro frontends. So you don't have a lot of burden in addition, because in general you always should deal with strategic design. Because if you have a large system where several teams implement parts of it, then it makes a lot of sense to have verticals that align with the business. So strategic design, domain-driven design might make sense even though you don't go with micro frontends. And you have the same situation with design systems and starter kits and libraries to make it easier for new people, team members and teams to onboard. Getting development or developer feedback is also not the worst idea in general, I would say, and so on and so forth. So the thing is, yeah, there are several challenges. We have to apply strategies, but some of the strategies we need even without micro frontends. So now, what is the cost of dealing with micro frontends and applying all those strategies? Well, the thing is, when you go with micro frontends, usually you have several stream-aligned teams in terms of team topologies, teams that work on their vertical, teams that provide business value on a regular basis, hopefully without interruptions. That's why they need to be autonomous. However, we also need a platform team for micro frontends. A platform team that is deciding for or against the strategies we have discussed before, and a platform team that is putting some of those strategies in helper libraries or in an internal framework or in your micro frontend platform. So the thing is, I have consulted a lot of teams or a lot of companies using micro frontends. And all the companies that have been successful with those approaches had a dedicated platform team that were solving issues, applying strategies, providing libraries and helper functions. So this is really vital. This platform team does not need to be huge. I've seen platform teams of 2 or 3 people serving up to 80 or even more stream-aligned teams working on their micro frontends. 80 or even more, 80. So it's quite a number, isn't it? So this does not need to be large, this platform team, but they really need to be experts on the used framework or frameworks, and they need to be experts when it comes to JavaScript itself. So they need to know how the framework works, what happens underneath the covers, because only then they can deal with technical issues that might arise when you load 2 frameworks into one browser window. Yeah. So the key takeaway here is you need a platform team, otherwise you will have an issue. And this platform team will just provide their platform, their libraries, their guidelines, their frameworks. So in team topologies, we call this acts as a service. They provide their stuff as a service because they cannot directly work with all the teams. Nevertheless, they will go out to the teams, they will work a bit with them, they will shadow them and find out which challenges they have so that they can address those challenges in the platform. Another thing we need to respect is we need to do a bit more architectural work. We need to evaluate different options, we need to facilitate decisions, we need to communicate those decisions so that the stream-aligned teams working on the micro frontends know why they need to do it this or that way. Because otherwise it's depressing if they are just told, do this, do that, without knowing why we need to do it. Well, we need to tell them you need to do it that way so that it fits into the micro frontend shell. Also, those points here should not come as a surprise for you, because those are 3 of the many tasks of a typical software architect. However, if we talk about micro frontends, we need to address those topics, those tasks a bit more, because there are some additional challenges and some additional decisions to be made. So you might say now, yeah, this is exactly what we need, because we have a huge amount of teams. They shall be stream aligned. They shall be capable of delivering business value on a regular basis without any interruptions. And so they shall be autonomous. And in this case, you go with concepts we have discussed before. Or perhaps you say, well, this all is a bit too much for us. We just have one team or a very tiny amount of teams, so we don't want to have the overhead. And then the question is, what's the alternative? And in those cases, what we are proposing to our customers is a monolith, a modular monolith. So we go with one monolithic application. It's one application we are deploying. However, internally, this application is sliced into verticals. And one more time, different teams take care of those verticals. That means we have some amount of autonomy. And also we try to minimize the dependencies between them so that they can do their own decisions, so that they don't need to communicate with all the other teams when they want to provide business value. But still, it's one application that is compiled together, it's optimized, so we can use tree shaking to remove everything we don't need, and everything is usually deployed together. So we get some amount of autonomy, but not the full amount. However, we also get not the full amount of challenges. If you want to implement something like this, like a large-scale monolith, then you need a smart build system, because you don't want to build everything time and again. You just want to rebuild what you've changed so far, and you just want to retest and relint what you have changed or what has been affected by a change. And so a smart build system can take care of this. And one build system I really love to use in the Angular space is Unmasked. And it also comes with first-class support for React and also support for other frameworks. There are some alternatives out there, but I really go with Unmasked. It also feels a bit like the Angular CLI, so it's not a big deal to switch over to it. And yeah, you get incremental compilations and tests. You get everything done in parallel. And yeah, so going with Unmasked is not a bad idea. Besides all of this, Unmasked allows you to enforce modularization. You can enforce this on a library level. You can say this library that is just a part of my monolith is not allowed to access that library. And this in turn allows us to decouple our verticals. And besides this, as mentioned, we get incremental CI/CD, we get a build cache so that we don't need to rebuild something the colleagues already rebuilt, or to retest something the colleagues already retested. And we get everything done in parallel by means of the so-called Unmasked cloud. So some people say we don't want to have that many libraries to subdivide the application into parts. We just want to go with folders. And that's why my colleague Rainer Hanekamp implemented the TS Sheriff, which is basically a quite smart and nice ESLint rule. It's just an ESLint rule. And this ESLint rule is highly inspired by Unmasked. However, it allows us to define boundaries on a per folder level, which means we can define that this folder is not allowed to grab over there into that folder. And one more time, this allows us to decouple our verticals so that they can grow and evolve independently. This works with and without Unmasked. And in my example, I'm still going with Unmasked, but I'm switching out the modularization of Unmasked for the modularization of Sheriff, because I want to do it on a per folder basis. So let's have a look into a demonstration of this. In this demonstration, here I have an application, it's called Flights. And as you see here, this application has been subdivided into domains. Different teams work on those domains. We can only define code owners for those domains, which means that if I change something in the domain ticketing, people from the ticketing domain need to do a review in order to land my pull request. And if something is changing something someone is changing something in the check-in domain, people from the check-in domain have to do the code review here. And of course, we have here a shared vertical that can be used by all the domains, because sometimes we need to share stuff, especially technical stuff like authentication or our design system. I would be careful when it comes to sharing use case specific, domain specific stuff, because the idea is to decouple domains from each other. So here we have our shared vertical, here we have our ticketing domain, and the ticketing domain is subdivided into some further modules in a data module talking to the backend and into two features. And one of those features contains here my flight search component. It's a traditional Angular component. And please remember, we are still, you see it here in the ticketing domain. And if I want to grab over into a foreign domain, into my luggage domain, I'm getting a hit on my fingers. Rainer, my colleague, is hitting my fingers. He is always hitting me, but it's for the better, because now we see, well, that's not allowed. This is not the idea of our verticalized architecture, to directly grab over into another domain and to use something from over there. No, please don't use it. The linting error we see here is that we seem to be in ticketing. It seems to be a feature of ticketing. And because of the rules we've defined with Sheriff, we are not allowed to grab over into the luggage domain. So better not do this. And this is not only shown as a linting error here in the IDE, we also get the same error when we start the linder on the console. So here we see several linting errors, but in between we also see ours. We are in feature booking, we are in ticketing and in a feature, and we don't have clearance. Don't have clearance for domain luggage. Don't grab over there, hands off. And having this on the console is really vital, because that means we can automate this check. We can automate it when someone checks source code in, we can perform this check, or if someone wants to merge their pull request, we can perform this check. And if we find those violations, we prevent checking in or merging this pull request. And so we don't have any broken windows anymore. Our overarching architecture, our verticalization is enforced. Quite smart, isn't it? So let me come to a conclusion. What did we see today? We have seen at the beginning, it's first and foremost about verticals. So in the beginning, we should not think that much about how to implement it. First of all, we need to identify good verticals, good business domains that don't need to know much about each other, good business domains that can be modeled separately. This also means we need to apply ideas from strategic design and perhaps even ideas from event storming. Remember the picture I've shown you before, because we need some proven strategies to identify those verticals. Then it's about several challenges and solutions when we try to implement verticals as micro frontends. There are several benefits. Don't forget about them, but we also have to deal with several challenges, and for this we have some solution strategies. We need a platform team. All the companies I have consulted in terms of micro frontends, and trust me, I've really consulted a huge amount of companies in terms of micro frontends. All the companies that have been successful are going with a platform team. It does not be a huge team, it does not need to be a huge team, but they have to be knowledgeable in terms of the used frameworks and JavaScript in general. They need to know what's going on underneath the covers so that they can provide solutions with their platform, with their libraries, guidelines, frameworks. If you say, well, this is too much for me, then a good alternative would be a monolith, a modular monolith. And when we go with this approach, we can use something like an X and or Sheriff to make sure that one vertical is not bleeding into another vertical. And at the end of the day, you need to evaluate if micro frontends pay off for you. If you have a lot of systems and a lot of teams, then it might be quite smart to go with micro frontends. If you only have a small amount of teams and if they can work in the same repository together, perhaps a modular monolith, a monolith would be the better solution. So at the end of the day, you need to evaluate, and yeah, this is also one of the jobs of a software architect, especially if we don't go with a default architecture. And there is one last thing, and please remember it, namely, good fences make good neighbors. It's all about the business domains. It's all about the verticals. So thanks for having me. I've already uploaded my material to my blog. You find it there. And follow me on X Twitter to stay in contact. Thank you.